Good evening, everyone. Are my slides visible? Hello. Am I audible to everyone? Hello. Are my slides visible? Can anyone confirm?
No, sir. Slides are not visible, sir.
Is it visible now?
Yes, sir. Yes, sir. Visible, sir.
Thank you. Good evening, everyone. So this is 8th tutorial on the course, The Joy of Computing Using Python. I am Manikandan, a second year PMR fellow at IIT Bombay. So today we'll discuss some practice problems based on the course contents, week 8 of the course contents. So as usual, I have some tutorial questions for you. So the first question asks, which of the following options correctly represent the full form of acronyms NLTK and WADER? So in week 8, you would have come across the sentiment analysis of Facebook data. So with regards to that, what are the acronyms of NLTK and WADER? So these are packages used for sentiment analysis. So there are 4 options given. So type in the chat box which of the expansions you think is right for NLTK and WADER. Okay, so I'll give away the answer. So the answer is option 2. Okay, so NLTK stands for Natural Language Toolkit. So that is used to, so if we give supply a text to the to this package. So it will evaluate whether emotion is negative, positive, or neutral. Okay. So if it is a very negative thing, like you're feeling alone or something, so it will count it as negative. If it's a very neutral tone thing, it will give it as a neutral. If it's a very positive, joyful thing, it will classify as a positive statement. So Vader is a package which will give points for that. How much, what's the degree of positivity or what is the degree of negativity in the statement. So the Vader package, it does that evaluation. So using these two packages combined, we can do sentiment analysis for any given text. Okay. Yeah. So after that, so the second question asks us to predict the output for this code snippet, where string 1 is defined. So that's a string that says hi Amitabh, and in the second line there's a print statement, and inside the print function we are sorting the string. Okay, so basically we are printing the sorted string which is given by string 1 in the first line. Okay, so what will be the output of this print statement? So what will it print? Okay, so based on, so you need to know that you will be familiar if you have gone through the week 8 contents. So sorting is done based on the ASCII values of a given string. Okay. So based on the ASCII values of all the characters given in this string, which of the following do you think is the answer of the like what will be shown with the print statement? Basically you are printing a sorted string, so you need to identify which of the following options is the sorted string. B. Okay. Okay, so one of you has responded B. Yeah, B seems to be close, but you have to notice that there is a space also. Okay, so space has a much lower ASCII value than the exclamation. Okay, so based on that logic, we conclude option 1 is the right answer. Okay, so in this string, even the space is counted. Okay, so ASCII value of space will be allotted some number, so that is found to be less than the ASCII value of exclamation mark. After that, the alphabets are arranged in the ASCII value. So first capital letters and then small letters. Okay, so this is the order of precedence. So I hope this is clear with everyone. If you have any doubts, please ask. Okay, so if there is no doubt, we'll go to the next question. So next question, we are given a code snippet. So which of the following scenarios in the options does the following code represent? So the control starts from here, like first we are importing the random library, and then from here it will go to line 10. Okay, because line 2 to 8 they come inside a function which will be called later. Okay, so the control flow is like it will go to line 1 and then the computer will read line 10. So a variable amount is initialized to 0, and then in a for loop which is running for 365 times, okay, because the last number won't be considered. Okay, so it will run from 1 to 365. So that's how range is defined. Okay, so for 365 times we are incrementing the amount by itself and the output of a function play. Okay, so play function is defined here. So from line 12 control will go to line 2. Okay, we are going to the definition of play and we'll see what it returns back. So once play is called, what it does, it will ask us to input a random number between 1 and 10. Okay, that is stored in A, and a random number between 1 and 10 is generated by the computer itself, and that is stored in R. So based on our guess and the randomly generated number by the computer, if both are equal, we'll return 1, else we'll return 0. Okay, so this seems like a guessing game. Okay. If our guess A is equal to a random guess generated by a second player or a computer, if our guess is right, we are guessing this R. Okay, if our guess is equal to the R that is generated by the second player or the computer, we win and we return 1. Okay, and our amount, basically our points, it is increasing by 1. Okay, so based on this logic, in the following options, which of the following scenarios does it represent at its best? A, okay. So yes. So what does option A say? A person goes to the bar for a year. Daily he guesses a number from 1 to 10. If the guessed number is equal to the newly number randomly generated by the bar authority, he gains 1 gold coin. Yes, so option A is right. So why this is right? It's because the daily guess, that is A, and the number randomly generated by the bar authority, that is R. If his guess is right, okay, then he gains 1 gold coin. So that is that gain is quantified here. Okay, play returns 1 if A is equal to R. Okay, so that 1 will be added incrementally for 365 days. So that's why it's for a year. Okay, so we are identifying the period is 1 year based on the range of this loop, 365. Okay, so 365 times this operation is being repeated. Okay, daily he is doing this guessing game. Okay, so if you have any doubts, please ask. Otherwise, we will go to the next question. So similar to the last time, we are given a code snippet, and which of the scenarios in the option does the following code best represent? Okay, similar to last time, we are importing the random library, and then we are defining a function. So control goes all the way here. A variable s is initialized to 0, and the for loop runs 100 times. Okay, for each time we are incrementing this variable s by the output of play divided by 100. So from here we are calling this function. So this function returns certain number. Okay, so that is divided by 10 iteratively, like for 100 times. So that is divided by 100 and then added to s. Okay, so that will be our updated s. So this takes place repeatedly. So what does this function play do? So similar to last time, a variable amount amt that is initialized to 0, and a for loop is initiated that will run for 100 times, and each time a random number is generated, so that the random number lies between 0 and 1. Okay, so that is called a uniform distribution. Whatever the probability is, it will range lie between 0 and 1. So probability always lesser than 1, less than or equal to 1, or greater than or equal to 0. Okay, so that's what this random.uniform function does. So if the generated probability, if it is lesser than 0.5, we are incrementing the amount by 1 and we are returning it. So based on this logic, so whatever the amount is returned, that is divided by 100 and then stored into s, and then this is repeatedly done for 100 times. Okay, so based on this logic, what do you think out of these 4 options best represent the following code? So please type your response in the chat box, whatever you think, or if you have any doubt, please ask. Okay, so one of you answered A. Bhargavi answered A. So yeah, A is the right answer. That's because, what does A say? So this code is simulating a gameplay 100 times. Okay, in each play, so 100 times the gameplay that is taken care of, that is taken care by this loop. Okay, so this 100 times is taken care here. Okay, so in each play, a coin is tossed 100 times, and the player is given the money equal to the number of hits he gets. Okay. So in tossing a coin, the probability of getting a head is 50-50. Yeah. So that is taken care here. Okay, so if you consider a uniform distribution, it will look like a bell curve. Okay, so it will run from -infinity to infinity. whatever probability you are expecting, that is area under the curve. Okay. So uniform distribution has a mean 0 and standard deviation 1. Okay, and it is not skewed. There is no skewness in it. Okay, so whatever 50% chance that lies left of 0.5, so probability equal to 0.5 will lie exactly in the middle. Okay, p equals 0.5, or in this case it is r. Okay, generally probability is denoted by p. Okay, so whatever, if anything lies left of it, so that will be considered as a 50-50 chance. Okay. So that is denoted by this heads. Okay, so since this is done 100 times, so you can the percentage will be converted to the actual number. So the probability of heads will be converted to a number of heads. Okay, so then the code displays the average money earned by the player amongst all 100 plays. So that averaging is done over here. Okay, whatever amount we are getting, it's getting divided by 100. So it will be like amount 1 plus amount 2 plus amount 3 all the way till n. Everything is being divided by 100. Okay, the common denominator will be 100. So that is the average among 100 plays. Okay, so this is how you decode this code and relate to the given option by analyzing all these parameters. Okay, so we'll go to the next question. So what will be the output of this following code? Okay, so this one is a bit tricky. We are initializing a dictionary called dict age, and the dict age we are assigning some keys and corresponding values. So keys are the names, 4 names are given, and their corresponding ages are given as values. Okay, so we are defining this dictionary dict age that is captured in dict1. Okay, that is captured like this, and then we are generating a list that contains the values in the dictionary dict age. Okay, so all these ages 20, 10, 40, 30, etc., all these things will be captured in the list L. Okay, and then line 9, we are changing the first element. Okay, we are changing the first element in the list L to 90. Okay, then we are printing L. So what will it show? What will be the print statement's output? Okay, okay, for this it will appear as B, but I want to demonstrate this in okay, let us see. I'll open Anaconda. Do we have it opened? Yeah, spider is open. Yeah. So I had written this code here. Okay. So when I run this, okay, I am missing one line. Dictionary 1 equals age. Let's see. Equals 30. So dict 1 equals dict underscore age. Okay, and then this line is done. L of 0 is equals 90. Okay, so I'll clear the console and run again. Oh no, this line is wrong. L equals dict underscore age dot values. So checking every line. Okay, now I run. Yeah, so I'm getting an error. So this error says that dict values object does not support the item assignment. So what does this mean is, so whatever change you want to, so I'm changing the age of a person, so that has to be done directly in the dictionary itself. Okay, so I cannot create a list containing all the values corresponding to a dictionary and then change that list, so that wouldn't effectively change anything. Okay, so this kind of assignment is not helpful. If I want to make any change, it should be directly in the dictionary itself. Okay, so if you are not clear with this, so what I suggest is, whatever you have, you search online. Okay, so I'm just yeah, so I just had searched this error in ChatGPT. So what does that give? So the error message, type error dict values object does not support the assignment, is raised when you try to modify an item in the dictionary using a dict values object instead of the dict object itself. Okay, so if I alter the list containing the values of the dictionary, that is not going to help. I have to make changes in the dictionary itself. Okay, so here's an example of how this error can occur. So they have a dictionary defined myDict which has some keys and values. Okay, and so the values of the dictionary are stored in this object mydict values. So if I change the first element of this values list to 4, so it will throw up this error. Okay, as you can see in the example, trying to modify the first item in the mydict values object raises an error. Okay, to modify items in a dictionary, you need to use the dict object instead of the dict values. For example, that kind of change can be done by changing the first element of the dictionary itself. Okay, so this changing the first value to 4 should be done like this, by addressing the corresponding key and then changing its value to 4. When you do this kind of updation and you print the dictionary, you get the desired change. Okay, so this is the right way to alter data in dictionary. Okay, so if you are stuck anywhere, you can use this kind of tool and see what the error is if you want to know more information about it. Okay, so that's how you do it. So the so answer to this one is, it will throw an error. So we move on to question number 8. So which of the following scenarios in the options does the following code represent? Again, we are importing the random library, and we are initializing a dictionary dict age. Okay, so that is empty, and then we are adding some keys and corresponding values in the dictionary. Okay, so these are like names and their corresponding ages. So that's the data the dictionary contains. Again, we are converting this all the values are converted into list and captured in the object L. Okay, so that is done, and we create another dictionary dict1. So that is empty, that's just initialized, and then an object L name is created, which captures the keys of the dictionary dict age. Okay, so the ages so the names are captured here, okay, in L name, and variable I is initialized to 0 and variable previous is initialized to 0. Okay, so a for loop is initiated. So for each element in dict age, so okay, so for each element is increased, so that is assigned to the previous element. Previous is the variable that is set to 0 initially, so it's like 0 plus L of I. Okay, L of I is L of 0 in the first instance. Okay, so L of 0 will be 20, the first age. Okay, so it's like in the first iteration, dict 1 of each, so each in the first iteration will be Arun. Okay, so Arun's age is initialized to so it's basically dict 1 of each Arun is equal to 0 plus 20. So that is what this line is doing. Okay, so Arun's age is equal to 0 plus 20. So that's what this line 15 is doing. And in line 16, this kind of updation is done for the previous iteration. So once the first person is done, in the second instance of the loop, the first person's age will become the previous person's age. Okay, so that is what is defined here. And then the iterator I is increased by 1 for each run of the loop. Okay, so remember I is not the iterator for the for loop, okay, but it is incremented to address to run through each person's age. Okay, so that will run through each elements of the list L. So that is incremented every time when we go to each person. Okay, finally the dictionary 1 is printed. Okay, so that's what is all doing. It is it is cumulatively adding the previous person's age to the current person's age. Okay, so that is what is done between these lines. Okay, so because in this second instance it will be like dictionary 1, the second person Bhima's age is equal to Arun's age, because that is done in the last iteration here. So this will be updated to Arun's age plus Bhima's age. Okay, so their age is being added cumulatively. So remember that. So that cumulative ages are captured in this dict1. Okay, after that we are generating a random integer between 0 and sum of all their ages. Okay, so what is given in the bracket corresponds to these ages. Okay, so between these, in this range, a random number is generated. We are printing that. Again, one more for loop is initiated for each in dict1. Okay, for each person in dict1, in dictionary which in which the keys are the person's names and the values are cumulative ages. So if R is lesser than dict1 of each, we are printing give all the money to each, and there is a break. Okay, so based on this cumulative age addition and this random number test, out of the following options, what do you think is does the code best represent? Any guesses? Okay, so this may seem a little complicated. So To answer this, you must be familiar with this cumulative distribution curve. So I have one image here. Mm. So yes, so cumulative distribution curve, it goes like this. It's like a S-shaped curve. Okay, so it's like so I'll draw here. So in y-axis it's the cumulative age C, and in x-axis it is the person, okay, P. So it will go like this kind of curve, S-shaped curve. Okay, so at the tail of this curve it's almost zero, and over here it is the sum of all these age, all the person's ages. Okay, so that is the limit. Okay, so when you go from each person, again if you take area under this curve, let's say who is the youngest here in the chronological order. If we go in the alphabetical order, if we choose, it's like, so cumulative age of Arun will be 20. So let's say that is somewhere here, 20. Okay, so cumulative age of Chirag will be how much? So that will be 20 plus 10 plus 40, that will be 70. So that will lie somewhere here. Okay, so based on that, we can see that however older is this person, how much older this person is, that much is the area under this curve. Okay, so that probability can be compared with this like this kind of. So older this person, higher is his cumulative age, the more probability that a random number picked between 0 and sum of all the ages is lesser than that. Okay, so the oldest person like is Chirag. So if his age is like, so his cumulative age almost touches this maximum limit. Okay, so whatever number R will be generated, that will be definitely less than this cumulative age. Volume too slow. Okay, am I clear now? Okay, so what I was explaining is, higher the cumulative age, higher is the probability that this random number is generated between 0 and sum of all the ages, that is less than the cumulative age. Okay, so it's like the cumulative age of the oldest person will be equal to sum of all the ages. Okay, so his cumulative age is somewhere here. Okay, so let's calculate that. 20, 30, 100. Okay, so that is 100 total sum. So over here random number is generated between 0 and 100 minus 1, 99. Okay, so what it says is, So when the oldest person's cumulative age is 100, that is definitely greater than whatever random generator is generated between 0 and 99. Okay, so all the money will go to him. Is that clear? So we can clearly choose this option. That so it will appear like that, but yeah, for each so we don't know which person is getting picked here. Okay, so I'm saying the case for the oldest person. So let's say if some other person, so the second oldest person is Deepak, so his cumulative age will be 30 plus 20 60, so that will lie somewhere here. Let's say 60 is here. Okay, so let's say 60 is somewhere like here. So what is the probability that the random number picked between 0 and 99 is lesser than 60? So that probability is lesser, right? It's lesser than 1. So when the oldest person was chosen, it was for sure 100 is greater than the maximum limit 99, so all the money will go to him. If the second oldest person is chosen, there is a only 60% chance that he will get his share of money. Okay, so we can conclude that money is given to a person with a probability proportional to his or her age. Okay, so this may seem a bit odd, but if you apply the real numbers and do one calculation for yourself, you will realize it, why it is so. So if you are dealing with thermodynamics or anything, like I don't know which course you all of you are in, so in any stage if you come across thermodynamics or statistical mechanics, so there will be a test called Monte Carlo test. So that will require this kind of random number generation, so that each random number generation will be corresponding to each arrangement of atoms and corresponding to a certain energy level. So that energy level, is it lesser than the predicted energy level? That kind of test will be conducted. So if that test is passed, the atom will jump and will go to a higher energy state. That kind of Monte Carlo jump test will be done. So in your higher semesters, if you come across that, you will realize what you are doing here. Okay, so question number 9. So a code snippet similar to the last time is given, except that we are having some change in how the money is allocated. So it's just saying print give all the money to maximum of dictionary items. Okay, so you can ignore this operator thing for now. Just consider till here. Based on this logic, out of the 4 options, what do you think is best represented by this code? So as usual, a dictionary is created with names as the keys and their corresponding ages as values. Okay, so it is saying print give all the money to maximum of the dictionary age dot items. Simply calculating the maximum age of these key values. cases. Okay, so what it does is, so I'll give you the answer. So all the money is given to the older person, because it is this max function. What it does, it is in the dictionary, out of these key values, it is taking the maximum, and the print statement says give all the money to the person with highest age. Okay, so we are done with the quiz. So there are some programming assignments. So please open Spider in your laptops and try to do the programming assignments along with me. Okay, so in this question, given a list L of integers, write a program to print this list L after removing all the duplicate values with the original order preserved. Okay, an example is given. If the input list is containing these numbers, the duplicate whatever repeating numbers, they are removed. Okay, for example, 24 is repeated, it's removed. 88 is repeated, removed. 155 is repeated, removed. So the duplicates are removed. We are not removing the first instance of this repeating numbers. Okay, 120 is also removed. So what is left? 12, 24, 35, 88, 120, 155. So that should be your output. Okay, so the explanation, as I had said, the third, 7th and 9th element of the list has been removed because it was already present. Okay, even the 8th element also. So yeah, using this logic, so your input format should be that in one line take the elements of the list L with each element separated by a space, and the output element should be print. Output format is that print all the elements of the modified list in one line with each element separated by a space. Okay, so one more example is given. 4 numbers are there, 24 is repeated, cut off, the remaining 3 numbers are presented as the output. Okay, so I'll give you a few minutes. Take a common number. It's like you should identify which numbers are repeating, and the duplicate should be removed from the original list, and whatever is remaining, that should be separated as the output. Okay, is it clear? Okay, so whatever list you have, so try for this input. Okay, whatever duplicate whatever numbers are coming in the repeating for the second time or third time, they should be removed off. Okay, none of the elements should be repeating itself. The output should be in such format. Okay, so the first part of the problem is you create a list. Okay, so you ask the user to input numbers that are separated by space. Okay, so create a list and then ask the user to input each number and then assign that number to each element of the list. Okay, so that is first part of the problem. After the list initialization is done, you call a function which will remove the duplicates from the list. So think about how you can do that. If you're stuck anywhere, please let me know. Okay, so if you're stuck, so these are the solutions. So the control is will first approach here. So this is the order you should type your code. First you write this line, you create an empty list li. So in the li you are asking the user to input some integers that are separated by a space. Okay, so after that you are creating an object that will capture the new list after removing all the duplicates. So you are calling a function remove duplicate, which will take the original list li and then it will supply a new list in which the duplicates are removed. So we are calling this function. So from here the control will go here. Okay, so basically after typing all these things, then you need to define your remove duplicate function. Then you put your cursor on top and start defining the function remove duplicate. So a new list is created, empty. So a set is created called scene. Okay, for each item in li, the old list, if item is not in scene, add that item to the set scene. Okay, so basically initially the the set scene, that is empty. So whatever item is in L, the first item in the list Li, that will be added to this set scene. Okay, that is happening here. But once uh, the iteration goes to a repeated element, okay, so that will not be added to this set scene, because it has to go through this if condition. If item is not in scene, if the item is already not present in this set scene, only then it will be added. If the number is already present in scene, it won't be added. Okay, so any number can be added to the set only once. Okay, so only the items which are satisfying this condition, only the unique items will be passed through this part of the code. Only those items will qualify this if test. Okay, so they are added to the set scene, and then those items are also appended to the new list LA. Okay, so whatever non-repeating entries items, so they will be appended to the new list here. Okay, so then we are returning the new list to here. So line 15 and 16, they are just in printing all the elements separated by a space. Okay, so all elements in X, they are being printed with a space. That's all. So if you're most of you might have thought till this line, so how you define this function using a set item, that might have been new to you, so that's why I showed the solution. Okay, so try the next problem. So assignment 3 asks us that we are defining a term panagram. Panagram is a sentence containing every 26 letters in English alphabet. Okay, so given a string S, check if the string is panagram or not. So the input format is, the file line contains the sentence, the first line contains the sentence S. Okay, so your input is basically a sentence, and the output should be print yes or no, accordingly whether the sentence is a panagram or not. An example is given. Okay, so this sentence contains all the 26 alphabets. Okay, all the 26 letters in English alphabet are here, so we are getting an output yes. Okay, so try to solve this problem. So I'll give you some time, try on your own. If you have any doubts, please ask. So your task is to input a sentence and then find it whether it is a panagram or not. Check if the sentence contains all the 26 letters in English alphabet. If it contains, your output should be yes, otherwise no. So let's show you the solutions to this code. Okay, so this is the order in which you start coding. So you define the driver program first. So this is your main program. Okay. So in this you are asking the user to input a sentence. Okay. So you're just calling this input function. Whatever sentence you enter, it is captured in this object sentence. Okay. And simply our task is to check if this is a panagram. Okay. The sentence is taken as an input. We are calling a function check panagram. If it returns true, then yes, otherwise the sentence is not a panagram. Okay. So the definition of this function check panagram goes here. Okay. So over here the sentence S is taken as input. Okay. So over here the input is taken in the form of S. An empty list is created. Okay. So after this empty list is created, we are adding 26 elements to this list, and each of the element is false. So the reason why we are doing this kind of an assignment will be clear if we go over the next sections of the code. So basically in this list, every element is false. 26 times false is repeated in this list. Okay, so that's all this list contains. After that, you convert the sentence to lowercase and then iterate over the sentence. Okay. For each alphabet C in the sentence S, so dot lower will convert everything into lowercase. Okay. If we don't encounter a space, okay, if we are not encountering a space, we are encountering an alphabet. For that, list of the ASCII value of the element that we are encountering minus the ASCII value of A, that will be equal to true. Okay, so we are making each corresponding end which is not a non-space. Okay, so that we are making as true. Okay. So the letters we are encountering, all of them are converted into true. If we don't encounter, we should encounter all these letters, and then only then it will be converted to true. So the letter which is not found in the sentence, that will remain false. Okay, so we are checking if any character is missing, and then the function should return false. Okay, so for ch, a character in a list, if anything is remaining as false, if that is not updated to true, then we are going to return false. Otherwise, if nothing remains false, all of them are true, we are returning true. True means we have encountered that number, alphabet, that's all. Okay, so why we are doing this kind of weird assignment to true is because we are converting everything into small cases. So ASCII value of A, if I remember right, it is something like 32. So let's take it as 32 for now. Okay, so if we encounter A, our C will be 32. So this A is reference A. This is the character A. That is not, that is not being read from the part of the sentence. This is standard A. That ASCII value is 32. And then for each alphabet in the given sentence, that will be iterated using the iterator C. Okay. So if this C is equal to A, it will be like so the ASCII value of the A that we found in the sentence, that is 32, and the ASCII value of standard alphabet A, that is also 32. So effectively they'll cancel out to be 0. So list of 0 will be out of these 26 elements in the list. So the first element in the list of 0 will flip from false to true. Okay, so we have concluded that in the 26 falses, the first one is turned to true. So A is encountered. So that is what we are symbolically meaning, logically. Okay, so the first element in the list is converted from false to true. Okay, I hope this is clear. So similarly, if we encounter B, it will be 33 minus 32. Okay, so 33 minus 32 will be 1. So in the second element in the list, that will be flipped to turn from false to true. We can say that we have encountered B also. Same way it will go till all the way from A to Z. So if we encountered all the alphabets from A to Z, all the 26 elements, all the 26 falses in this initial list, it will be switched to true. Then we can conclude that we have encountered all the alphabets in the letters in the English alphabet. Okay, if anything is missing, how do we check anything is missing? If any of the elements in the list, it remains false. So that is what we are doing here. 15 to 18 is doing that only. So for any element in CH in the list, if it remains false, then return false, or else default it will return true. Okay, so if this statement is true, okay, so this true will be taken here. Okay, if this statement is true, print yes, that is the sentence is a panagram. Okay, so is everyone clear with this, or did I lose anyone? If it's not clear, please, I can explain it again. Please ask if you have any doubts. Okay. So then we'll go to the last question for today. So over here we are given a string S of lowercase letters. Okay, so our task is to remove the consecutive vowels from the string S. After removing, the order of the original list should be preserved. Okay, so that is the task. The input format is you enter a sentence in a single line, output format is like print the sentence after removing the consecutive vowels. So we are not supposed to remove all the vowels, but only the consecutive vowels. Okay. For example, in this sentence, your article is in Q. So in this sentence, consecutive vowels are here, like after O, a vowel U is being repeated. So we'll remove that. Okay, and in Q, it's like after each U, a E is repeating, and U is also, yeah. So after this U, all of them are consecutive vowels. So we are striking out all of them. Okay, and your output sentence is what remains after this removal of consecutive vowels. Okay, so the explanation is just what I had said. So in the first word, O and U are appearing together, hence the second letter U is removed. In the fifth word, Q, the U, E, U, E are appearing together, hence whatever is after the first U, it is removed. Okay, so using this logic, try to write a code. If you have any doubts, ask me.
Sir, do we have to remove consecutive vowels except for the first one?
Yeah. So consecutive vowels is like when you encounter one vowel, and then whatever, so you keep that one, but whatever is coming next to it, you remove that.
Okay, sir.
Yeah. So it's like you should compare the ith element with the I minus 1 element. Okay, you have to check whether these two are vowels. If these are, so this is the I minus 1 is the previous term. Okay, I minus 1 will be the alphabet that is appearing first, and I will be the alphabet that is appearing next to I minus 1. So you will preserve this. So in this case, let's say this is O and this is U. We'll keep I minus 1 because we encountered this first. We'll preserve this and we'll cut off ith index. We'll cut off U. So you have to, for all comparisons, you have to only take two alphabets at once and then compare. Everyone got the answer. Okay, if you are trying, I'll give you a couple of minutes more, then I'll show you the solution. Okay, so I'll show you the solutions now. Okay, so the main part of the code is here. You will take a string as an input, and then you are calling a function that will remove vowels when you supply the string as an input. Okay, so the function is defined like this. Remove vowels is defined here. So we are printing the first character. So I told you that whatever comparison is to be done, it should be done in pairs. So we are seeing what character is the first one. We are printing that and seeing that. Okay, and we are looping for each other character to check for each other character. So for an iterate I in range 1 to length of string, all of the elements will be covered. Okay, using this for loop, we are for all the elements we are comparing the consecutive characters. So what we are checking is if the alphabet at I minus 1th position, is it a vowel? If that is not equal to true, or the character at I, if that is not equal, that is not a string. I'm sorry. If that is not a vowel, we are printing that. Okay, so basically, so it will be clear if I explain this functionality of this function is vowel. So this whatever alphabet you supply to it, it will check whether it is it's a vowel or not. Okay, whatever alphabet C is supplied to it, it is checking whether it is A, E, I or O or U. Okay, it is returning that. Okay, so the what it will be returned is so because this is a logical statement, it will return either true or false. So if C is either one of the vowels, this function will return true. Okay, basically all this function is vowel is doing, it's checking if this letter C is a vowel or not. If it's a vowel, it will return true, otherwise it returns false. Okay, so the alphabet at I minus 1th position, if it's a vowel, it will return true. Okay, so whatever is in this brackets, this will be true. Okay, so effectively this true not equal to true is not true itself. Okay, so that is a false. Okay, so this kind, so that is what this is doing. So it's checking whether all it needs is this shouldn't return a true. That's all. This shouldn't return a true means we don't have consecutive vowels. Okay, this checks if we have a vowel or not. This statement, this if statement 9, 20 and 21, so this checks whether the consecutive vowels are found consecutively or not. Okay, so if this if statement is satisfied, we are printing the string I, string at the alphabet at ith position of the string. Okay, so the consecutive letters are being checked here, and each of them, whether it is a vowel or not, that is checked by calling this function isVow. Okay, so once the consecutive alphabets test is done, if this if statement should be effectively true, only then the alphabet will be printed. Okay, so for each alphabet at ith position, we are comparing with the previous one, whether it is a vowel or not. So if the previous one is also a vowel and the current one is also a vowel, this if statement will not be satisfied. So this if statement, if this logicality, it's a bit complicated to realize how it works, but once you write it on paper and see, you will understand how this works. Basically, it is checking either the alphabet at ith position, is it a vowel? And I minus 1 position alphabet, if that is also a vowel, this if statement will disqualify, and this print won't be followed. Okay. So basically we want this is vowel to return false. So if this returns false, we can say that false is not equal to true. Okay, so that statement, this outer brackets, this one will be effectively true, right? So if this turns out to be false, I'm just using F for false. So if false is, so what this it is evaluating, false is not equal to true. That is a true statement in itself. Okay, and then we are having an OR. So if this it is itself is satisfied, if there is one true, then whatever is right to this OR statement, we don't need to even evaluate. We can just straight away print this string I. Okay, but if this is invalid, if this is vowel returns true, then it will become like true not equal to true. So that is not true. Okay, so it will be like, so if at I minus 1, if we find a vowel at that position, this will return true. Okay, so it will be like, I'm evaluating this statement, it will be like true not equal to true. Okay, so I'm evaluating till here, left of OR. Okay, so is this statement true? No. So it's like saying 1 is not equal to 1. So that is false, right? Okay. Now I said that at I minus 1, we found a vowel. Let's say at ith position, we found a consonant, not a vowel. Okay. At I, what will this return? So it is checking whether it's a vowel or not. It's false. Okay, so it will be like false not equal to true. That will be F not equal to true. So is this statement true? So it's saying like 0 is not equal to 1. So that is true, right? So these two statements, these two logical evaluations are separated by an OR. Okay. Finally, what we are evaluating? False or true. Okay. So according to the truth table, if either one of them is true, OR function will give true, right? So effectively true. true. Okay. So what did I say? At I minus 1 vowel, at I it was a consonant. Okay, so if this pair is found, effectively we are getting true. So if true, print this consonant. That's all. So that's all this code is doing. Okay, now let's say this at ith position it's a vowel. Then what will happen? If it's a vowel, this will be true. So it will say like true not equal to true. That will be false. False or false, that will be false. So effectively this if statement will return false. So if this if statement is false, we anything inside this if block will not be considered. So we won't print anything. Okay, I hope this is clear now. It's just that the expressions are it's easier to explain if it's in person class, but online it's difficult for you to understand. But once you understand the truth table, it will be clear for you. Okay, so that's the last problem for today. If you have any doubts, please ask. Otherwise, we'll close for today. Okay, so if all of you got that, we'll close for today. Thank you.